recorded. All right, good morning. I hope everybody had a good holiday. Mine was meh. I am wearing a heart monitor. Just so you know, there's nothing wrong with me. As far as we know, we're just double checking. It's one of the joys of being a diabetic. So I am going to be working on getting your grades in. I know there were some issues with some of the work. I think I fixed most of it. If you did not get your test taken, you better just pray when I get there that I'm smiling and I've had some caffeine in me, because you've had ample time to contact me. So let's get started. Now we're going to do parts of Module 4 before the semester exam. Good morning, Kylie.
Good morning.
And the reason we're doing parts is we're hitting the parts that need to be taught so that you can have success if we don't make it through the rest of it, which we're going to have to do because you need this information, right? But it's all about polynomial functions. And so what we're going to do today is a polynomial addition. Tomorrow, polynomial subtraction. Thursday, polynomial multiplication. Friday is going to be long division. Monday will be synthetic division. Tuesday will be a quiz. Tuesday or Thursday will be a quiz. And for those of you who have to take a semester exam, I will answer questions, because what I'm going to do basically is release all your tests so you can look at them. It will be a comprehensive everything we've done test. Multiple choice online. God, I hope so. All right, so today we're going to call this polynomial operations. Yes, ma'am?
Carlin said that Sophia said that it's not posted.
What's not posted?
I don't know. He just told me to say that.
Am I presenting?
I'm not on there yet.
Okay. Yeah, okay. Ask him to clarify, please.
It shows that they're presenting. Let me ask him.
It is, because I can look at the back and see.
He said the assignment.
I'll look at that in a moment. So day one is adding. All right. Now, guys, there's some things that we're going to define right up front. And we're going to work on this. But there are some definitions that you need. So what is a polynomial? It is a monomial or a sum of two monomials. Will somebody Google the definition of monomial for me?
Monomial?
Yeah, just like I spelled it, please. Or more. What is it?
It says it's an expression of the form k times x, and this is an n, where k is a real number and n is a positive integer.
So, say that again. Is there not a definition with words? Sorry. Okay, so I was just looking, so I needed to see what it says. All right, guys, and this is exactly what a monomial is. It's k x to the n. K is a whole number generally, right? Is that what it says? Could be a fraction. What is k?
Hang on, I got
N is a positive whole number exponent. Positive
K
whole.
is a real number and N is a positive integer.
Okay, so real numbers mean that this is a real number. And the reason I added this, and I just thought about it, is because I'm talking about what a monomial is and what it isn't. It is not two numbers. If you notice what's happening here, multiplication, right? That's it. It has to have positive exponents. You can't take the square root. X cannot be in the denominator. That's to be classified as a monomial. We're still going to deal with it, but they're not called monomials. So binomial is the sum of two monomials. And a trinomial is the sum of three monomials. It's very specific for a reason. So the degree of a polynomial is the greatest degree of any term in the monomial. Greatest degree of any term in the monomial. Should be polynomial. Yeah. Should be in the polynomial. Now guys, I will show you how to find the degree of something. Polynomial. And last but not least, what does it mean for a set to be closed? I had never heard of this before until I went to graduate school. And apparently I just hadn't taught it, or I missed it, or it didn't get taught to me. But when is a set closed? Okay. Set is closed if and only if, which means it has to meet all the conditions. It cannot meet partial conditions. It cannot meet half of the condition. It's got to meet both. An operation any two elements of the set produce another element of the set. All right? And just so you know, the set of polynomials is closed under addition and subtraction. That's it. Those are all the vocabulary for today. And if you have questions about it, you can email me and I can answer them, or you can ask them. So let's get down to what we're doing. So let's look at some of these things and determine whether they are polynomials or not. And if they are, what are their degrees? So, example 1. Determine whether the expression is a polynomial. If so, give the degree. Now, I am not going to do the examples that basically that are on in your textbook that are on page, oh, hold on, where'd it go? I'm not going to do the example 1 because identify polynomials A, B, and C because it tells you. So what we are going to look at is, yeah, we are. We're going to do the first one. Let's look at it. So let's look at A. Is this a polynomial? X to the 6th plus the cube root of x minus 4. Polynomial or not? Is this a monomial? We are still writing. The answer is not a polynomial. Why? The cube root of x is not a monomial. That's all there is to it, guys. Because if you write it like you think it would be, which means you go x to the 1/3, right there, that tells you what? By definition, we said your exponent had to be a positive whole number. Is this a positive whole number? Yay, nay? Hold on. Nope. And that's why it's not a monomial. We're going to do the B portion of this. All right. So example 1B is 5a to the 4th b plus 3a squared b to the 7th minus 4. Is it a polynomial? Why, yes it is. So yes, polynomial. What's the degree? All right, the degree. So what we're going to do to find the degree, okay, constants, numbers have no degree, they're 0. So, but you add the exponent. So you're going to say 5a to the 4th b. You're going to say, well, 5 is 0 plus 4 plus 1, and that is what? Hi, guys. Good morning. I want somebody to answer me. What's this answer? What's 0 plus 4 plus 1? It is 5. Okay, now let's look at we're not going to do 4 because it doesn't have one. So let's look at 3a squared b to the 7. Well, 3 doesn't have one. A is 2 plus b, which is 7, which is 9. So this is a 9, has a degree of 9. And that's the hard part for today, guys. Example 2. Maybe if I can find my example 2. Mm-hmm. Yes, I always do. I generally try to. That doesn't mean, okay, so example 2. Let's just do this. We've got 6x cubed plus 7x squared minus 2x plus 5 plus x cubed minus 4x squared minus 8x plus 1. There are 2 strategies you can use here, and I'm going to show you both. I don't care which strategy you use. I have a preference because that's the way I was taught way back when I started doing algebra. And so that's the one I am most comfortable with. And so here, this is called adding vertically, horizontally. Sorry. And with that, guys, you're just going to group like terms. So my first group is going to be 6x cubed plus x cubed, close that parentheses, plus what's next? 7x squared minus 4x squared, close parentheses, plus negative 2x minus 8x. Could I put plus negative 8x? You could. I'm not. I will. Plus 5 plus 1. Now, guys, all I did was group like terms. Remember, like terms, the exponent part has to be exactly the same. As in, I couldn't put x cubed and x squared together. And then all we do is we add. Remember, there's a 1 here that's understood. 6 plus 1 is so 1. 7x squared plus 3x squared. Well, negative 2x plus negative 8x is minus 10x plus 6. All right, here's the way I'm more comfortable with, and this is the way you will see me do things when we start adding and subtracting and doing some stuff. Hold up, please. Just because I'm more comfortable with it that way. Some people like to see it this way. It hurts my eyes. I like this way. Add vertically. So I'm going to say 6x cubed plus 7x squared minus 2x plus 5. Now you notice, make sure they are descending and that all your exponents are there. And if you'll notice, we have 3x, there's the 3, there's the 2, and there's 1, and then there's no x. We're writing this in standard form, which means you go from the largest exponent down. Plus, what I'm going to do is I'm going to line up. So I'm going to say x cubed minus 4x squared minus 8x plus 1. I think we teach this here a lot. I know this is how I teach it. because then they're all lined up, and I can just go, oh, 6 plus 1 is 7x cubed. 7x squared minus 4, that's plus 3x squared minus 10x plus 6. I don't care which way you do it. Choose a way. You need to be able to be comfortable with whatever way you want to do it. And yes, I have a preference, and that's just because that's the way I was taught. So let's do one more, and then you can do the assignment, which I will go check. So here's example 3. It's going to be, and basically we're going to add 2x cubed plus 9x squared plus 6x minus 3 plus, tell Carlin I may not have added it to the folder yet, but it should be on the online book. I think plus, because I've been trying to figure out what he was talking. 4x. What?
Oh, I've been trying to tell you since class started that it's not posted on the book.
It's not? I'll fix
No.
that. I can fix that.
Okay, thank you.
Anybody have a choice?
Vertically.
Thank you. So 2x cubed plus 9x squared plus 6x minus 3. 3, 2, 1. You don't want to skip numbers in here, basically what I'm saying with your exponents. Then I'm going to put 4x cubed minus 7x squared plus 5x. What happens if you're missing something, Miss Austin? You just add 0. So if I hadn't had an x squared term, you just put 0 there, 0x squared, because you can add anything to 0, right? So 2 plus 4 is 6. 9 minus 7 is 2. 6 plus 5 is 11. And negative 3 plus 0 is minus 3. And we are done. And that's it. Are there any questions?